In this video, we'll discuss the problem coin piles. Previously, this problem has been asked in Microsoft. So the problem says that you are given n piles of coins, each containing ai number of coins, right? So the ith pile is containing ai number of coins. So you have to find the minimum number of coins that you should remove such that the absolute difference between any two piles is at most k. So the problem says that they will give you n piles. So let's say the piles are like this: a1, a2 up till an, right? And the ith pile is having the number of coins as ai, right? So what the question says is that you have to choose one index I and another index j such that I is not equal to j. So you have to choose two different indexes in this particular array, and the target is that the absolute value of a of I minus a of j should be lesser equal to k, right? So this is the target that you want, that for any pair in this for any pair of I and j such that I is not equal to j, the absolute value of r of I minus r of j should be lesser equal to k. Now one more thing in this question is like you can understand that let's say you are given piles like 5, 7 and 9, like something like this. So if you remove one coin, so if you remove this, if you make this 8, so you are removing one coin, right? Another thing that you can do is, let's say if you are given 5, 7 and 9, right? So another thing that is given here in terms of note, that you can remove a coin, you can remove a pile by removing all the coins of that particular pile, right? So what you can do is, like, let's say if this is one of the piles, right? So what I can do is I can pay the cost, that is 5, that is ARRI. If I pay this much cost, complete cost, then I can mark it as 0. So will I consider it 7, 9 and 0? No, I'll directly discard this. So I'll say that okay, this pile never existed in the first place because I've paid a cost of 5 for removing it completely, right? So either you can remove it completely, then in that case you can pay the complete cost and you can remove it completely and you will not consider it further, or you can trim this off, right? So this is what you can do. Now what your task is to get this minimum done, right? So let's say if you are given as n is equal to 4, so you are given 4 elements, and let's say each of the elements is 2 to 2, right? And k value is nothing but 0, right? So in this case you can see that if you choose any I and any j, then the absolute difference between that is r of I minus r of j, absolute difference will come out to be equal to 0, right? So this will be the case. Now let's try and understand like what will happen if the situations are a little different. So let's say that if the case is such that you have been given an array like 7, 1 and 10. So in this case you will try to do what? You will try to think maybe in terms of maximums and minimums, or maybe you will try to sort it, right? Why you will try to sort it? Because you will say that like if I sort this, then what I can observe is, like, if I keep the difference between the minimum and the maximum at a check, if I keep this difference between the minimum and the maximum at the check, then maybe that is lesser equal to k. In that case, maybe I can achieve this particular target, right? So you will say that if I have 1 and 10, so basically what I can do is if you give me k as 3, right? So what I can do is, if I make if I can see, so currently I'm having 9, so that means that that's a lot. So what I can do is I can make it 4. That means I take I spent 6 coins. I have to pay a cost of 6 coins. Now what I do is I have 1 and 7, right? So this 7 and 3 are in check. Now I have 1 and 7. So for 1 and 7, what I can see is, if I have 1 and 7, so if I see this 7, so total difference comes out to be 6. So I need to make this as 4 as well. I need to pay a cost of 3. So total cost that I am paying is 9, right? But can I do is in a better manner? Yes, I can apply the thing that was given to me in note, that what I can do is I can take a particular pile, I can remove it completely and pay a cost of r of I. So if I take this particular pile, right, if you give me this particular pile, right, if I take this particular pile, then in that case I'm paying a cost of just 1 and I'm completely removing it. And after I remove this, so I pay a cost of just 1, right? I pay a cost of 1 in this case, and what I do, what I get is I get these two piles left, 7 and 10, and you can see that they are in a check because the k value is 3 and the absolute difference is less or equal to k, right? So that's the thing. So this is the operation. That's why this operation is important. So what you can maybe think of is, initially you can think of like in terms of sorting. That's pretty much clear. But if you will think in terms of maximum or maximum, minimum, or 2 pointers, then the task will become difficult, right? Let's try and understand another case. So let's say if I was given a case like this, let's say if it was something like this, let's say it was 3, 10, 12. It was 3, 10, 12. Then let's say it was 16, let's say it was 19, let's say it was 25, right? So this was the case that was given to me. So what I can understand is, like let's say if I was here, right, if I was at this particular index, so if I'm considering this particular index, so what I can say is, let's say if this is the index, right? So if let's say this is the minimum value that I have, so can I say that I have to remove the other smaller values? if I have to consider this current index as the minimum, if I have to consider current array phi as the minimum value, why I'm considering this as the minimum? Because then in that case, the maximum that I can go is array phi plus k, right? If array phi is 10, then the maximum, let's say k value is 3. So then the maximum that I can go is till 13, right? That is still that is the maximum till that which I can go. So basically, what I can do is let's try and do it this way. So first of all, let's try and consider. So what if I remove this this starting part, right? If I want to make this 10 as the minimum element, right? So that array phi is the minimum, and the maximum that I can have in this range is array phi plus k. Other than this, if any value is having other than this, suppose k value is 3, so if any value is having other than 13, so I have to trim them off, right? So if I'm removing this starting part, then the cost that I'm paying is 3, right? And then after that, what I am doing is I'm checking, like I find this particular index, that from this particular index I'll be starting to pay the extra cost, right? That is, I have to subtract 13 from this, right? So basically, how can I find this particular index? So since you can see that I have sorted the array, so what I can do is I can directly jump to this particular index using the concept that is upper bound, right? I can directly apply the concept of upper bound and I can get to this particular index. Now upper bound, what I can do is I can apply the upper bound like this. I can write upper bound a comma a plus n comma a of I plus k, right? So basically I have to find all the elements that are greater than a of I plus k, that are greater than 15. I have to find the index of all those elements, right? And then I can consider to subtract 13 from each, right? Now this will be a tedious task, right? Why? Because let's suppose that I am removing it like this. Let's say that if I am removing it like this, suppose that I am currently at this index and I remove this much starting, so that means that I'm paying a cost of 13, right? Now let's suppose that if I'm removing this much part, suppose I'm removing this much part, then you will say that I'll calculate 3 plus 10 plus 12, right? Like this. And for the rest of the part also I'll be calculating. No, that in that case it will be a kind of brute force approach. But do we know any technique that can help us to, if I want to remove this much segment, that can give me directly the answer? Yes, the technique is the prefix sum technique, right? So I can directly calculate the prefix sum and I can get this, right? Suppose I want to my current index I is this, then if I have the prefix sum, then I can prefix sum of I minus 1 will tell me, okay, the prefix sum was this much, right? So I have removed this much coins, this much is the cost that I have paid, right? So that's what I can do. So basically prefix sum of I is equal to nothing but prefix sum of I minus 1 plus this value, that is a of I, right? So this is how you calculate the prefix sum, in case if you did not know. Basically if this is the given array A, right, to me, in that case the prefix sum for this particular array will be what? This will be 3, this will be 13, this will become nothing but 25, this will become 41, this will become 60, and this will become 85, right? So prefix sum, you keep on adding, right? Now the next thing is that this prefix sum part is done, right? So that's how you calculate the prefix sum, but that is not the eventual target that you want. The thing that you want is, let's say I took this particular index, right? So suppose I took this particular index. So before that I removed everything. So how will I get it? So prefix sum of I minus 1 will tell me that what is the start from the starting, how many coins I've removed. Suppose I chose this particular index I, right? So in that case I'm removing this much part. So prefix of I minus 1 will tell me that, okay, I'm removing this much part, right? So it will be told to me by the prefix of I minus 1. So suppose that I am currently at an index like this and I'm removing this much part, right? So prefix of I minus 1 will tell me, so this is the cost from the starting. Now what I want is now this is the index that will be telling me index. I'll get this index through the upper bound, right? So index is what? Index is giving me the value of the index of that element which is greater than the value 13, right? Value 13 is what? A of I plus k, right? Because I'm considering that, okay, this a of I is the minimum that I am currently having. Now what I can have is, if I see this particular array, so I can see that I'm subtracting 13 from each of the values, right? I can say that currently my index is marking to this particular point and I'm subtracting 13 from each of the values, right? If I'm subtracting 13 from each of the values, so that's also taking time, right? And maybe I can do it in an efficient manner. Now can prefix sum help me to calculate the prefix sum of this particular segment? Yes. Basically you can do prefix of r minus prefix of L minus 1 kind of thing, and that's help you, right? So basically what you want is, you want the prefix sum of this much particular part, right? So what I can suggest is, like, how you can find it. So you can do this thing, basically you can do prefix of n minus 1, right? Prefix of n minus 1 will tell me what? Prefix of n minus 1 will be the prefix sum for the whole array, right? And now if I calculate the prefix sum till this, if I know the prefix sum till this index, and if this index is what? This index is INDEX, right? So what I do is, if I subtract minus prefix sum of index minus 1. If I do this particular thing, then in that case what I'll get, basically the prefix sum till here and till here, right? So if I subtract these two, so I'll get the prefix sum of this particular part. Now is that sufficient? No, I don't need to add the complete prefix sum because I'm okay with values, but I just want I don't want 16 from it. I want 16 minus 13, that is 3. I want 3. So what I can do is, how many elements are lying in this particular range? So I can say that my index is here, right? Index is here, total elements are n. So what I can do is, I know that if I want to remove them, if I want to trim this part, so what I can do is, I can from this particular prefix sum that I'm getting for this particular segment, I don't want to remove it completely, right? I want to just trim 13. So from every value I'm subtracting 13. So that means how many values I'm having in this part? So n minus index is the number of values that I'm having, and into I'm multiplying what? A of I plus k. Right, so this is the part that you need to notice. Now that's how you will be calculating for every index, like considering that the current A of I is the minimum that I have. So if you are removing the starting part, so that current array of I becomes the minimum. So in that case, the cost will be P of I minus 1, and the prefix sum that you'll have for this particular region, that is from 16 till 25, will be given by P of n minus 1 minus prefix of index minus 1. And then what you'll do is, you don't want the prefix sum of this range, right? You will not directly add it. Basically you want to subtract 13 13 13 from it. So you'll calculate how many elements are there. So total n minus index elements are there, and from that you are subtracting kind of 13, right? Array of I plus k. So that's why you are subtracting. So that basically from this particular thing, that is from this particular range, what you'll get is, you'll get this thing, 16 minus 13 plus 19 minus 13 plus 25 minus 13, right? So whatever part you want to trim, so that part you are adding to your cost, right? So that's how you are doing it. Now there's one more challenge that lies ahead. So suppose that if I had an array like this, 3 3 and 10, let's say 10, and let's say 12, let's say it was 16, it was 20, right? So suppose I was at this particular index, so that means I've chosen this particular index I as my minimum element, right? So now I can see that this particular index, when I move my I to this particular index, then will I choose this again? No, I'll not want to choose this again, right? Similarly, if I've chosen this already as the minimum, so will I want to choose this 3? No, I will not want to do that, right? Because I've already done it. So that's why what will happen is, basically if your adjacent elements are the same, if this is I plus 1 kind of, or let's say this is I minus 1, whatever. So if the adjacent elements are the same, then you can directly move to the next element, right? From this 10 you can directly move to this 12. So that is also one thing that you need to notice. And in that case, basically what you can do is, you can have a starting value that will tell you that, okay, prefix of I minus 1 is the starting value that you're removing. So the answer will be nothing but prefix of I minus 1 plus prefix of what, n minus 1 minus prefix of index minus 1, right? Basically this is the part, minus what, n minus index, that is the number of elements, into A of I plus k, that is how many 13s you want to reduce, right? From, like, let's say if you are here, right? If your index is here, so in that case n minus index will give me 2, and 2 into 13 will give me 26, because I want to reduce 13 from this and 13 from this, right? So total prefix sum I'll get from this particular thing, right? Total prefix sum will be what? Total prefix sum will be 36 minus what? I want to subtract 26 from it, right? So I want 10. So this particular region will give me that particular value, right? This particular region will give me that value, and basically I'm removing this much segment, right? I'm removing this much part, so that's why I'm paying a cost of P of I minus 1 as well, right? So let's quickly try and write the code for this particular question. So what I'll be doing first of all is, I'll be sorting this particular given array. So sort a comma a plus n, right? So I'll directly sort it in ascending order. Then what I'll have is, I'll have a ascending prefix sum, right? So prefix of 0 is equal to what? Prefix of 0 is equal to nothing but a of 0, that is the very first element. After that, what I'll do is, I'll start for, and what I'll do is, for I starts from 1 and I is lesser than n, so I'll calculate the prefix sum for the rest of the indexes. And what I'll do is, prefix of I is equal to prefix of I minus 1 plus a of I, right? Once I'm done with this part, so what I'll do is, I need an answer, right? I need a resultant answer. So I can mark my result as nothing but int underscore max. That is the, since I want the minimum value, so I can initialize my answer or the resultant variable to a infinity kind of thing, right? And apart from this, do I need anything else? Yes, I need the starting part as well. The starting part that I'm removing, I can initially mark it as 0. Then what I can do is, I can start my iteration, right? Int I starts from 0, I is lesser than n, and I plus plus, right? I'll be doing this part. And then after this, in the end, you know that I'll be returning the result, because like I'll be having the minimum result with me, right? So in the end, I'll be simply returning the result. That is something that I know. But before that, before that, what I'll be doing in this part, right? So I know for sure, like I'll be finding the index, right? So I talked about the index thing, that is the values from which you start need to trim, right? So let's say if the value of ARR of I is 10 and K value is 3, so that means you can bear till 13, but after 13 you need to remove the number of coins, right? So you want the index of the for very first element that is greater than 13, so that's why you'll apply a upper bound, right? So you'll apply a upper bound, and then what you'll do is a comma a plus n and comma a of I plus k. So you are finding all the index of the element that is just greater than a of I plus k, right? And you do this, so you will get the index. Then once you are done with this part, so basically you can say that maybe you will just store the result, that is result is equal to nothing but minimum of result comma this thing, that is maybe some start value that I have, right? Start value, or you can say prefix of if I'll talk about this, so it can be like prefix of I minus 1 thing, right? Prefix of I minus 1 plus what? Prefix of n minus 1 minus prefix of n minus 1 minus prefix of index minus 1, and what I'm subtracting from this particular part, like this is the part that I'm getting for the prefix sum for the elements that are greater than 13, right? Let's say array 5 that are greater than array 5. Now I don't want to remove all this part, I just wanted to trim this, right? If you give me a value 16 and 20, then I don't want to completely remove 36. I want to do 16 minus 13, that is 3. So that is the cost, that is the number of coins that I want to remove. Like from 16 I want to remove if the value is 13, so I want to remove 3 coins, and from 20 I want to remove the total 6 coins, right? So that's what I want. So basically what I'll do is n minus, this will be nothing but n minus index, it will give me the number of 13s, right? If I have just 16 and 20, in that case I'll have this value as 2, right? So into what? Into nothing but a of I plus k, right? This part will be done. Now I'll say that okay, this part is done, right? But I told you that there can be repetitions, right? I told you that there can be repetitions, like if suppose that this is the case, right? So there can be a thing like if you have considered this as a of I, right, once, like you have considered this as minimum, then you will not want to consider this as minimum, right? Because this will be repetitive. So what you can do is you can skip this part, right? So that for that, what you'll be doing is your I is greater than 0, right? And what you will do is you'll mark your I greater than 0. Initially you'll mark your start at 0. Why? Because initially you'll think that okay, you are not removing any element from the array, right? And after this, what you'll do is if I is greater than 0 and a of I is not equal to a of I minus 1, right? So in that case, what I'll do is I'll mark my start, that is the part that I'm removing is nothing but p of I minus 1. So the starting part that I'm removing, considering that a of I is my minimum element, right? So that's why I'll, instead of this, I'll write start here, right? Now let's try and compile this particular code and see whether it's working or not. So there's some compilation issue. Yeah, I have not declared I, so let's quickly declare I. Again, some compilation issues. Yes, I need to change the array name. I've taken as a, n and k. So once I'm done with this part, so I can directly compile and check. So you can see that I'm getting the expected sample output. Now let's see whether it's working on the test cases or not. So you can see that this problem got accepted, right? So that's how you have to do this particular problem. So for if I'll talk a brief summary about this problem. So basically why you did this, because you did p of I minus 1, right? Then what you did, p of n minus 1 minus p of index minus 1, index was telling me the next greater element, right? The greater than a of I plus k, right? Minus what? I don't want to remove all the, like if you have like values like 10, 12 and 16, and let's say if you have 10, 12, 16 and 20, then I don't want to completely remove these values, right? I just want to subtract 13, 13 from it. So 2 times I want to do that. So that's why what I'll do is I'll check how many n's I want to remove. So that's why I'll do minus n minus index, right? N minus index will give me the number of elements. In this case, it will give me 2, right? And into a of I plus k, right? So this is how I'm doing it. And why I did this thing, that is this. If I is greater than 0 and adjacent element, because if I've already made a particular, I don't want repetitive elements to be considered as minimum again and again, because that will take a lot of time, right? So that's how I've done it. And the time complexity for this particular approach, since I'm just sorting, so the time complexity for this particular approach, the time complexity is going to be nothing but order of n log n, right? Time complexity. and the space complexity that I am going to take is order of n. Why? Because I have taken a prefix sum, right? So this problem was asked in Microsoft, and it was a kind of medium hard problem. Make sure to try this out as well, and if you liked it, so you can write understood in the chat. Thanks a lot for watching. I'll see you in the next video. Till then, take care.